This is the casing of the 2 BCL back-to-back centrifugal compressor, which has 2 compression stages in a single casing. The suction and delivery nozzles, which are welded to the casing. The supports which fix the casing to the compressor skid. Casing sizes and the number of impellers are indicated in the compressor designations by the digits following the compressor model. For example, 2 BCL 807 is the designation for a 2-stage back-to-back compressor, size 800 with 7 impellers. Vertically split casings are used for relatively high working pressures and/or specific gases. The shape and thickness of the casings depend on the pressure ratings. This is a horizontally split diaphragm bundle. The slot for the seal O-ring. The O-ring is fitted before closing the lower half of the diaphragm bundle.
Piano, piano. Lascia da fare, inizia a seguire.
Suction, intermediate, and discharge diagrams create the gas flow path within the stationary components. The suction diaphragm conveys the gas into the eye of the first impeller. The annular suction chamber of the diaphragm bundle, where a fin is made to direct the flow of gas from the suction volute to the eye of the first impeller. Intermediate diaphragms perform the dual function of forming the diffuser passage and the return passage to channel gas to the eye of the next impeller. The discharge diaphragm forms the diffuser for the last impeller as well as the discharge volute. The diaphragms are usually horizontally split and are made of cast iron, forged steel, or stainless steel. You can see the special aerodynamic design conveying the suction gas to the eye of the impeller without forming a vortex. The bolts which lock the diffusers in position in the diaphragm bundle so that they do not fall out when the upper half is turned over to be coupled with the lower half. The labyrinth seals, installed between the diaphragm bundle diffusers and the rotor impellers. These also are split in half. The centerline lock screws for the diaphragm bundle labyrinth seals. They ensure that the seals are not dislodged. Easily removable labyrinth seals are installed on the diaphragms at the impeller shrouds to prevent return flow from discharge to suction, and on the shaft sleeves to eliminate interstage leakage. This is the compressor rotor. It is composed of closed-type impellers, shrink-fitted and keyed to the shaft. The balancing drum, required to balance the thrust that is created on the rotor during compressor operation. The spacer rings that are fitted between the impellers. Locking rings for the rotor. They tighten the impellers, spacers, and balancing drum into a single assembly. These are the seats on the rotating element of the compressor gas seals. This is a typical gearbox to centrifugal compressor drive coupling. The hubs of the coupling are force-fitted on the shafts, which are to be coupled, and coupled to the spacer. The spacer transmits motion from one shaft to another. The centrifugal compressor has 2 journal bearings and 1 thrust bearing. Tilting pad journal bearings are generally used. This is the journal bearing number 2, i.e., the one on the non-drive end. This is the journal bearing number 1, i.e., the one on the drive end. This is the compressor thrust bearing. Here it is shown in its housing. These are the tilting pads of the bearing. Some of these hold on the thermocouple heads. The filament is lodged in a slot made in the body of the bearing. Double-acting tilting pad thrust bearings are installed. The bearing pads can be fitted with thermocouple elements for temperature detection and with load cells in high-pressure applications to measure actual axial thrust load. Shaft end seals eliminate or minimize compressed gas leakage from the compressor casing, as well as ingestion of air into the casing. The type of seals depends on a compressor's service. The compressor rotor is then lowered into the lower half of the diaphragm bundle. The radial position of the rotor, in relation to the diaphragms, is the same as the rotor would have resting on the journal bearing pads once the compressor is completely assembled. Now the procedure for closing the diaphragm bundle begins. Great care is necessary when closing the diaphragm bundle to avoid damaging any components. Before proceeding with tightening the centerline bolts, it must be checked that the holes for pins in the outer casing of the diaphragm bundle match. Wheels, fitted on the lower half of the diaphragm bundle, which are used for sliding the bundle on instead of the metal when fitting the diaphragm bundle in the compressor casing. The diaphragm bundle is now installed in the compressor casing. What you can see here is the track which supports and guides the diaphragm bundle as it is being installed in the casing. The track has to be jacked at the free end. A special bracket with a wheel and stand is used to keep the bundle horizontal and parallel to the axis of the casing. A hydraulic jack with a movable support is used to push the bundle inside. The support is fixed to the track, leaving space for the jack to be fitted between the support and the bundle. And now all the tools used to install the diaphragm bundle are being removed. Now the suction and discharge end head covers are being fitted. This operation has to be done with great care to avoid damaging the balancing drum labyrinth seal installed on the head covers. Hence, the reason for special lifting tool being included among the special tools. It's also used for centering the head cover with respect to the casing and therefore in relation to the rotor. Once the head cover is in place, by means of two side brackets bolted to the casing, two jacking screws are tightened to shift the head cover into the casing. To secure in position the head covers, round segments are used. First, internal segments are installed. To carry out this operation, a special lifting tool is required. We are now showing the installation of internal locking segments. To secure them in place, locking screws are used. We're now showing the installation of external locking segments. To secure them in place, locking screws are used. After the head covers have been tightened, the end labyrinth seals are fitted. Both seals are lodged in the head covers. The labyrinth seals are fixed by a Seeger ring. Before starting to install the gas seals, it is essential to check that the rotor is in the center of the diaphragm bundle and to lock it in that position. Shaft end seals eliminate or minimize compressed gas leakage from the compressor casing, as well as ingestion of air into the casing. The type of seals depends on a compressor's service. And now, the dry seal is being inserted into the head cover by set screws. The rotor has to be lifted by half the radial clearance on the labyrinth seals in order to allow the seal to be freely fitted in position. To prevent the dry seal from being damaged, it is fitted with a fixture mounted between the seal stator and rotor. Once the seal is installed, this fixture is removed. Now the third stage seal is being installed, following the same procedure as for the gas seal.
Aspetta un attimo, Vai, un po' dentro. Come dice la vita, dovrebbe essere già arrivata.
Now, the non-drive end bearing housing is being fitted.
Cosa ci si mette? Questo, vai, buttali. Aspetta però, quando riesci. Sì, sì. Non tanto però, sta tentando giù.
The thrust-bearing collar is force-fitted on the compressor rotor. The fixture used for force-fitting the collar consists of two hydraulic pumps, two flexible pipes with respective fittings, and the actual fixture for pushing the collar into position. A high-pressure pump and a low-pressure pump are used. The high-pressure one widens the inner diameter of the collar, and the low-pressure one pushes the collar into position. By using both pumps, the collar is fitted in the right position with respect to the rotor. Prior to releasing the pressure, which pushed the collar into position, it is recommended that it be held for about 10 minutes, as this allows the collar material to relax better. Now the thrust-bearing inboard thickness ring is installed. Now the drive end bearing housing is being fitted. Throughout all the previous operations, it is necessary to take great care that the thermocouple wires fitted on the bearings are not damaged. These are the compressor's radial vibration probes that are being fitted here. They are installed outside the casing and therefore without having to disassemble any compressor components. The probes are calibrated and secured by nuts arranged in boxes fitted on the outer casing. All thermocouple and RTD wires are connected to two terminal boards at the ends of the compressor. This is the casing of the 2 BCL back-to-back centrifugal compressor, which has two compression stages in a single casing. This is the fully assembled centrifugal compressor.